Hello students, today I want to present this topic called effect of an electric current on a substance. Topic 5 from 2. Before I start, let me just remind you that also we have a topic from 4, topic 4, electrochemistry. That topic is continuation of this topic. So under this topic we are going to learn the basic things. In more details, when you reach form 4, that's when you will learn in more details. Let me start. Effect of an electric current on a substance. We are going to learn 4 things under this topic, 4 subtopics. 1, but A here is electrical conductivity of solid, how solid conduct heat and electricity. B, electrical conductivity of an molten substance. C, electrical conductivity of an aqueous solution. And lastly, D, electrolysis process. For you to determine whether a substance will conduct an electric current or not, an electric circuit, which includes substance being tested, is used. A bulb is used to show whether a current is flowing when the circuit is completed. When the switch is closed, the bulb lights if the substance being tested allows a current to pass through it. The bulb does not light if the substance being tested does not allow a current to pass through it. Okay, so now this diagram that you see on your screen is called electrolytic cell. Yeah, now the features here we have the battery. A battery has the positive terminal and it has the negative terminal. The longer line is always represent the positive, the shorter one is negative terminal of the battery. In this case they have indicated, but sometimes they only show you the longer one and the smaller one. So you must know that the long one represents the positive terminal of the battery and the shorter one always represent negative terminal of the battery. Sometimes they show you they show you the same size, but one will be thick, the other one thin. In this case now we can say the thicker one represent positive and the thinner one represent the negative terminal of the battery. And here we have the switch controller. The bulb is here, the substance being tested is here. Next, now there's two rods that are dipped in the solution. We call it the electrode. So these two bars is called electrode. Most frequently we use graphite rod as an electrode because graphite is unreactive and also graphite is very cheap. But we have other reactive metal that we can use in place of graphite, and that is platinum and carbon. So the bulb will light if the substance being tested is a good conductor. The bulb will not light if the substance is a bad conductor. The graphite rod which carries the current into and out of the electrolyte is called electrode. So we can say electrode are rod which carry the current into and out of electrolyte. We are going to discuss what electrolyte is. We are going to define what electrolyte is at the end. Graphite rods are frequently used as an electrode because they are unreactive and it is very cheap. Unreactive metal electrodes such as platinum and copper can also be used as an electrode. The electrode connected to the positive terminal of the battery is called the anode, while the electrode connected to the negative terminal of the battery is called the cathode. We see this electrode is connected to the negative terminal of the battery and we call it the cathode, while the electrode that connected to the positive terminal of the battery is called the anode. So here now they told us that generally metals are good conductor of heat and electricity. For that one The bulb will light if a substance being tested allows a current to pass through it. The bulb does not light if the substance being tested does not allow an electric current to pass through it. Substances which allow an electric current to pass through them are called the conductor. We call it a conductor. While substances which do not allow an electric current to pass through is called non-conductor. They told us generally metals are good conductor of heat and electricity. In metals, the atoms are packed together very closely and they have a delocalized electron which move freely from one point to another within the structure. Graphite is a non-metal but it conducts an electric current. In graphite, the carbon atoms are bonded in such a way that the resulting structure has some delocalized electron. The delocalized electrons in metals and graphite are responsible for electrical conductivity in this substance. All solid substances that do not have delocalized electrons in their structure are non-conductor. The role of the battery in the circuit provides a necessary driving force or energy which makes the electron to flow in one direction through the circuit. So, in summary, they told us that metals are generally good conductor of heat and electricity. Substance that allowed an electric current to pass through is called conductor, while substances which do not allow an electric current to pass through them, we call it non-conductor. Metals are good conductor of heat and electricity because they have a delocalized electron. If you see all metals, they have positively charged ions. If it is group 1, it has positive 1 charged ions. Group 2, they have 2 charged ions. Group 3, they have 3 positive 3. Metals are good conductor of heat and electricity due to the presence of delocalized electrons. In exam, you can be asked why aluminum is better conductor of heat and electricity. So you can simply say aluminum has more delocalized electrons than others, than group 1 and 2. That's why aluminum is a better conductor of heat and electricity. All solid substances that conduct heat and electricity, they have delocalized electrons. All solids that do not conduct heat and electricity, they do not have a delocalized electrons. Graphite is only non-metal that conducts heat and electricity because also this one we have learned under topic structure and bonding where we have discussed diamond and graphite. And the next topic, carbon is common also. With your teacher, you are going to discuss graphite and diamond. Diamond and graphite are allotropes of carbon. Two stable allotropes of carbon are diamond and graphite. So, in diamond is the hardest known substance. Diamond, the 4 valence electron is used for bonding. Therefore, diamond does not have a delocalized electrons. That's why it's a bad conductor of heat and electricity. But in graphite, only 3 out of the 4 valence electron, only 3 is used for bonding. So the remaining 1 is a delocalized electrons. That's why we say graphite is a good conductor of heat and electricity due to the presence of 1 delocalized electrons. And remember, graphite is the only non-metal that conducts heat and electricity. Next, now we go to effect of conductivity on a molten substance. Molten substance, most example, they take lead-2-bromide and lead-2-iodide. This part you have to change this one. It should be lead-2-iodide, lead-2-iodide. And here we have shown you the diagram. When we lead-2-bromide and lead-2-iodide, this one is the ionic compound. The bond they have, this one is metal and non-metals. These two substances, they conduct heat and electricity when they are in molten form, but when they are in solid form, they do not conduct because ions are fixed by strong are fixed in one position. Ions are not free, but when melted, the ions become free and they start conducting heat and electricity. So we have said the electron that connects to the negative terminal of the battery is called the cathode. The electron that connects to the positive terminal of the battery is called the anode. When we heat this compound called lead-2-bromide, it forms lead-2 ion, and bromide ion. Remember, lead-2 ion, it has positively charged ions, and bromide ion has negatively charged ions. So since lead has a positive, it migrates toward the negative terminal of the battery. So the cathode we see a green beads of lead-2 ion of lead metal deposit. Bromide ions, since it has a negatively charged ions, it migrates toward the positive. We know that positive and negative attract each other. So here now we see the bromine gas. In the case of lead-2 iodide, when we melt this one, lead-2 ion is formed and bromide and iodide ion is formed. Lead-2 plus ion is formed and iodide ion is formed. Lead-2 bromide, since it's a positive, it migrates to the cathode negative terminal of the battery, while iodine ion, since it has a negatively charged ion, it migrates toward the anode, which we call it the positive terminal of the battery. Lead-2 bromide does not conduct an electric current in the solid state. However, it conducts an electric current when melted. Similarly, lead-2 iodide does not conduct in the solid state but does so when melted. Lead-2 bromide and lead-2 iodide are ionic compounds. Remember, a compound we have said are pure substance that made up of two or more elements chemically combined. And we have said ionic compound, they have two opposite charged ions. Positive charged ions, negative charged ions, or we can say ionic bond is a bond between metals and non-metals. Since we know that metals has positively charged ions, non-metals they have negatively charged ions. Ionic bond is there is a complete transfer of electrons from one atom to another, because metals normally they lose electron to become stable or to react. In other hand, non-metals they gain electron to react or to become stable. So there is a transfer of electron from metal to non-metals. The substance form is called ionic substance. In solid state, all ionic substances in solid state they do not conduct heat and electricity because the ions are fixed in one position. But when melted, the ions are free to go. The ions become mobile, that's why they conduct when they are in molten form. Heating or melting weaken this force, enabling the ions to move. The mobile ions in the melted are responsible for conductivity of lead-2 bromide and lead-2 iodide. They have taken these two examples, lead-2 bromide and lead-2 iodide, which are examinable. But remember, all other ionic substances they behave same. Other ionic substances do not conduct in solid state but conduct when in molten state due to the presence of a mobile ion. Next, now they told us that sugar, sulfur and wax do not conduct an electric current in solid state. When molten, they also do not conduct. These substances have a molecular structure and lack charged particles. The absence of charged particles is responsible for non-conductivity of an electric current in sugar, sulfur and wax. These three substances, not only these three, we have many molecular substances. Those substances which has molecular structure are normally bad conductor of heat and electricity, or we can say they are They are non-conductor of heat and electricity. They don't have the localized electron. They don't have free ions. Due to lack of particles, due to the lack of charged particles, they are non-conductor of heat and electricity. Metals are good conductor both in solid and in molten state because of the presence of the localized electron in their structure. When metals are melted, the localized electron remains mobile, enabling metal to be conductor in molten state. So in short, metals are good conductor of heat and electricity when they are in solid state, when they are in molten state, because they have the localized electron which are freely to move, which are freely or mobile. The melting point of metals is very high. Their conductivity in molten state may not easily be investigated in school laboratory because melting point is very high. Number C, we go to electrical conductivity of a substance in aqueous state. Aqueous means in solution form. Sodium chloride, cobalt 2 chloride, cobalt 2 sulfate do not conduct electricity in solid state, but when dissolved in water they conduct. Remember, when we dissolve in water, those salts, they become an aqueous solution. Solution of also they told us solution of sulfuric acid, hydrochloric acid, and sodium hydroxide. So here we have these acids, and we have sodium hydroxide and ammonia, which are base, were also found to conduct electricity. Aqueous solution of salt, base, and acid contains mobile ion. The mobile ions are responsible for electrical conductivity. When the circuit is completed, the positive ion in the solution moves toward the negative electrode that is cathode, while the negative ions move toward the positive electron and anode. In more details, we are going to learn in Form 4, God willing. So, in summary, it told us that the salts, acid, and base contains mobile ions. That's why they are good conductor of heat and electricity due to the presence of mobile ions. Here now we have the solution. If we take a salt or acid or base, we dissolve in water, they become an aqueous solution. So the negative parts, the negative charged ions migrate toward the positive, that is anode, while the negative one, the positive charged ions migrate toward the cathode, and then the bulb will light if a substance being tested is a good conductor of heat and electricity. An electric current is shown to move from positive terminal to the negative terminal. So the electric current move from positive to negative. So here now we can say this is the direction. The electric current move from positive to negative terminal of the battery, even though the electrons actually flow from negative to positive. They flow in the opposite direction. So here now we have the current, and here we have the electron. Electron move from negative to positive terminal of the battery, while the current move from positive to negative terminal of the battery. Next, now we go to electrolysis process. Electrolysis is just decomposing of a compound by passing an electric current through it. What products are formed when an electric current is passed through a molten lead-2 bromide? So let's see what will happen. Here now we have lead-2 bromide. We have said lead-2 bromide do not conduct heat and electricity when they are in solid form due to lack of free ions. But when we melt or when we add water, when it becomes an aqueous solution, it conducts heat and electricity. Then after adding water, so here now the ions become lead-2 ion and bromide ion. Lead-2 ion, since it has a positive charged ions, it migrates toward the cathode, where now it gains electrons to become lead metal. So we observe a gray beads of lead. Bromide ions, since it has a negative charge ions, it migrates toward the anode, the electron that connect to the positive terminal of the battery, and it forms a bromine gas, a red-brown gas of bromine. When the switch is on, a red vapor of bromine ions. The bromine gas, the color is red vapor, is produced at the anode, while gray beads of lead metals are formed. Let me repeat again. A red vapor of bromide ion is produced at the anode, while gray beads of lead metals are formed at the cathode. Bromine gas and lead metal are produced as a result of decomposing of lead-2 bromide by electric current. Lead-2 bromide is an electrolyte. So electrolytes are substances which, when melted or dissolved in water, conduct an electric current and get decomposed by the current. That's the definition of an electrolyte. Electrolyte, the substance which, when melted or dissolved in water, conduct an electric current. The process of decomposing an electrolyte by passing an electric current through it is called electrolysis process. And here we have at the cathode, for negative terminal of the battery, the positively charged ions lead-2 ions get attracted to the negatively charged cathode and migrate toward it. On reaching the cathode, the lead-2 ion gain electrons to form electrically neutral atoms of the lead metals. This metal is deposited as a gray beads at the cathode. Now we observe a gray beads at the cathode. This change is illustrated by the following equation. Here now we have an ionic equation. We have the equation lead-2 ion. An aqueous solution, it becomes lead metal, and we observe a gray beads of lead metal at the cathode. At the anode, the negatively charged bromide ions get attracted to the positively charged anode and migrate toward it. On reaching the anode, the bromide ion loses electrons to form bromine atom. The bromine atom combines to form diatomic molecule of bromine of a brown bromine gas. Remember, all halogens, we say they are diatomic molecular. They are formed a diatomic. And here we have the equation. Bromide ions, it become bromine gas, diatomic. Lead-2 bromide is an example of a binary electrolyte. This is because its melts contain only one type of cathode and one type of anode. When we melt, it forms only one positive ions and one negative ion. That's why we call it binary electrolyte. Next, now we go to application of electrolysis process. The process of electrolysis is applied in a process such as extraction of metals such as sodium, magnesium, and aluminum by electrolysis of their molten substance. Also, this application another application now we can take purification of metal. How to make metals pure. Purification of metals, we apply this electrolysis process. C. Electroplanting of metals such as iron to improve their appearance and preventing corrosion or coating, or we call it electroplanting of metals such as iron to improve their appearance and prevent corrosion. The manufacture of pure chemicals such as hydrogen gas, chlorine gas, and sodium hydroxide. So in summary of our topic here, we have said this topic is all about the basic So we have learned metals are good conductor of heat and electricity, while non-metals are non-conductor. Graphite is the only non-metal that is good conductor of heat and electricity due to the presence of the localized electron. 2. In metal and graphite, electrical conductivity is due to the presence of the localized electron in the structure. Electrolytes are substances which, when molten or dissolved in water, conduct an electric current and decompose. Solution of salt, acid, and base are electrolytes, means they only conduct when they are an aqueous solution or when they are molten. The electrical conductivity of electrolyte is due to the presence of mobile ions. Non-electrolytes are composed of molecular, hence they do not conduct an electric current whether solid, melted, or dissolved in water. Binary electrolytes are one which contains only one type of cation and one type of anion. When an electrolyte is electrolyzed, the positive ions always move to the negatively charged cathode, where they gain electron to form neutral atom. The negatively charged ions move to the positively charged anode, where they lose electron to form neutral atom. Graphite is the most commonly used electrode because it does not react with many electrolytes or their product, and it is cheap. So I would like to end this by these quizzes. So you try the following questions. Number 1, name the particles that are responsible for electrical conductivity in solid state, in molten or melt, in aqueous solution. Number 2, which give two properties of graphite that make it suitable for use as an electrode. Number 3, define the following: what is conductor, what is electrolyte, what is electrolysis, what is cathode, and what is anode. So before I end my video, I would like to take summary. So today we have learned the way I told you that this topic in more details we are going to learn when we reach Form 4 and a topic called electrochemistry. We have discussed three subtopics, or let me say 4 subtopics. 1, electrical conductivity of a solid, electrical conductivity of a molten substance, electrical conductivity of an aqueous solution, and lastly we have discussed electrolysis process. In summary, we have said electrical conductivity of a solid state, all solid substances that are good conductor of heat and electricity, is due to the presence of the localized electrons. Metals are generally good conductor of heat and electricity due to the presence of the localized electrons. Graphite is the only non-metal that are bad conductor, that are non-conductor because graphite is the only non-metal which are good conductor due to the presence of the localized electron. In graphite, the 4 valence carbon atom, only 3 is using for bonding. The remaining one it's now at the localized electrons. So all other non-metals are non-conductor except graphite, because graphite it has one localized electron, and that is responsibility. The electron is responsible for graphite's conductivity. Then in molten state we have said all ionic substances. Ionic substances are those substances which has ionic bond, the bond between metals and non-metals. Transfer of electron from one atom to another, resulting in the formation of two opposite charge, that's positive and negative. Metals they have positively charged ions, non-metals they have negative. So when they react, they form ionic compound or ionic substance. All ionic substances they conduct heat and electricity when they are molten or when they are in aqueous solution, because when it's in solid form, the ions are fixed by one are fixed by in one are fixed in one position. But when melted or when we dissolve water, the ions become very free. So all ionic substances they conduct heat and electricity when they are molten or when they are in aqueous solution due to free ions, due to moped ions. But when in solid forms, the ions are fixed in one position. Ionic substances are so many, all of them they conduct when they are molten instead. Then next we have discussed when they are in aqueous solution. Same to ionic substance. They only conduct when we add water, when it becomes dissolved. So ionic substances they are good conductor of heat and electricity when we melt or when we dissolve in water. Then we have said we have electrolytes. Electrolytes are those substances that conduct only when they are molten and when they are in aqueous solution. They only conduct when they are in molten solution or aqueous solution. But when they are solid, they do not conduct. Those substances called electrolytes. So we can say ionic substances are electrolytes. Next we have discussed electrolysis process. The most examinable part here is to know what will happen when we melt lead-2 bromide and lead-2 iodide. We must know how to state the observation. Then we must know the equation of the cathode and the equation of the anode. And lastly, we have discussed the summary of the topic. So this now is to end my topic. So wish you good luck in your academic.